Hey everybody, in this video we are going to find the volume of a cylinder. And the volume formula for a cylinder is area of base times height. And because the base is always going to be a circle, instead of putting area of base, we will substitute that with pi r squared, the area of a circle. So the formula will be pi r squared for area of the base times height, where r is for radius and h is for height, which is the distance between the two circular bases. So in order to find the volume of a cylinder, we need two things. We need the radius and we need the height. So in our first cylinder here, we have a radius of 6 and a height of 6. So the volume is pi 6 squared times 6. So in our calculator, we put in 6 squared times 6, and we get 216. So the exact answer is 216 pi inches cubed. So we'll do a few more cylinders like this, and then we'll get to some more real-world applications at the end. So our next cylinder, we have a diameter of 42, which means our radius, half of that is 21. So we have a 21-yard radius. So the volume, pi 21 squared times the height of 50. So we have 21 squared times 50, and that is 22,050. So the volume, the exact answer, is 22,050 times pi yards cubed. Our next cylinder is laying down on its side. The volume is pi times the radius, which is 17 squared, times the height. Now, height does not have to be top to bottom. It has to be base to base. From one circular base to the other is 25, so the height is 25. So we have 17 squared times 25, 7,225. So the volume is 7,225 pi feet cubed. Our next cylinder is oblique, so it's not just tipped over, it is slanted. So according to Cavalari's principle, we can use exactly the same formula for volume. So volume equals pi times the radius. Now the radius is 10, so 10 squared times the height, which is 15. So we have 10 squared times 15. We could probably do this one in our head. 10 squared is 100 times 15 is 1500. So we have a volume of 1500 pi meters cubed. Next we have one with a diameter of 12, which means we have a radius of 6. So the volume is pi 6 squared times 5. 6 squared times 5 is 180. So the volume is 180 pi meters cubed. Okay, now we'll do something more real world here. So you plan to fill a tube with concrete for a footing. So you're digging to put in a concrete footing for something. If you pour 1 cubic yard of concrete into this tube, what will be the depth of the concrete? Okay, so you might put in a footing for a mailbox, for a fence post, for a deck, anything that needs stability of concrete underground. Okay, so in order to find the depth of the concrete, we're going to use the formula volume equals pi r squared h, and we are given that the volume is 1 cubic yard, so the volume, V, is going to be 1 cubic yard. Unfortunately, the diameter here is in inches. So I need to take that cubic yard and convert it into cubic inches. So 1 cubic yard, that's 3 feet by 3 feet by 3 feet. And because a foot is 12 inches, that means a yard is 36 inches. So a cubic yard is 36 inches by 36 inches by 36 inches. Okay, so 36 times 36 times 36, which is the same as 36 cubed, is 46,656. 46,656 cubic inches. So the volume is 46,656. So 46,656 equals pi times the radius. The radius is 9 inches squared times the height, which we do not know. Okay, so what we can do to solve this in one move is divide by pi 9 squared. So the pi and the 9 squared cancel, so I'm just left with h. Okay, now in order to do this in one move, I need this denominator in parentheses. Otherwise, I'll divide by pi and then multiply my result by 9 squared. But I want to divide by pi 9 squared, so I need parentheses there. So I've got my 46,656 divided by parentheses pi 9 squared. And that is 183.35. And that's in inches. Okay? So let's convert that to feet to get maybe a little better idea of how deep this is. So we'll divide by 12 inches per foot, and we get 15.28 feet. Okay, so that's a pretty deep footing, so it's probably not for something like a mailbox. That's something that's going to stick up a decent ways above ground and is going to need quite a bit of stability underground. The cylinder shown is hollow in the middle. Find the volume. So we've got a 5-inch diameter, we've got a 4.5-inch height, and then we've got this hollow core here that is a 1-inch diameter. These happen to be the same as the dimensions of a normal roll of toilet paper. So what we're going to do is find the volume of the toilet paper on the roll. In order to do that, we need to find this outer volume and subtract the volume of the hollow part. So the volume is the outer volume, pi times the radius, which is half of 5, so 2.5, times the height, which is 4.5. Okay, so that's the outer volume, but we have to subtract this inner core here, so minus pi times the radius, which is 0.5 squared times 4.5. Okay, so to get an exact answer, I wouldn't use pi. I would have 2.5 squared times 4.5 minus 0.5 squared times 4.5, and that is 27. So the exact answer is 27 pi, and that is in inches cubed. Okay, now I like to give exact answers, but when I'm dealing with something that's a real-world object, that's when I give approximate answers. So I'm actually going to go ahead and multiply that by pi, and I'm in a mode that gives me 27 pi, so I'll change my mode to classic and multiply 27 times pi and get 84.82. So it's 84.82 cubic inches of toilet paper on the roll.